So when we have graphing quadratics, there are two forms for graphing quadratics, all right, or parabolas. One form, it can be written in the form y equals ax squared plus bx plus c, which is what we did last year. All right, there's also a second form. That second form is written as y equals a parentheses x minus h squared plus k. Notice inside the parentheses it's what? Negative, or it's the opposite. Outside the parentheses it's plus, which means it's the same. All right? So the thing that you need to remember now is the number in front, this, is called a vertical stretch if a is greater than 1, and it's a shrink if it's between 0 and 1. Listen to what I'm just saying now. All right? It's a stretch if it's greater than 1. It's a shrink if it is between 0 and 1. We'll get to it, I promise you. I promise. All right? Now, if it's less than 1, that means it would have to be negative. And if a is negative, we say that reflects over the x-axis. Come on now. So those are your choices. All right? If it's greater than 1, it's called a vertical stretch. If it's between 0 and 1, it's considered a shrink. And if it's negative, it reflects over the x-axis. Now, obviously, if it's negative 2, it's a vertical stretch. All right, if it's negative 1/2, we say it's a vertical shrink. Now, listen to what I'm trying to tell you. This number in front here literally just means you're multiplying the y value. All right, so you're multiplying the y value. If, for example, this is 3, you're really multiplying every y value by what? Negative 3. Over here, you're multiplying every y value by what? 2. So in your mind, if you multiply the y value by 2, that's making the y value larger. So we say it's a stretch. If you're multiplying it, for example, by 1/2, when you multiply the y value by 1/2, it's actually what? The graph is actually what? Shrinking. All right, quickly, come on. I'm not. No. Don't. We're getting to that. I promise. You should already know that anyway. All right. So again, the h here. Inside the parentheses, we say it's shifting what? Opposite, but shifting which direction? Right and left. Thank you very much. It's shifting right or left. All right? So in this case, we'd say it's shifted to the right. How many? 4. In this case, we'd say it's shifted to the... It's that simple. All right? This over here, what's outside the parentheses is shifting what? Up and down, right? So the transformations are knowledge. That's all. If you don't know that, you can't do the problem. All right? It's very simple. And the beauty of it is, once you understand the parent function, which is referred to in this case would be x squared, the most basic form, if you know the most basic form, then all of these transformations allow you to graph any of the equations. All right? So for a here, you would simply say it's shifting what? Right 4 and up 2. Then it would be reflected over the x-axis, and you say it's a vertical stretch of 3. Now, vertical stretch, VS, is perfectly fine. All right? So that's everything you need to write down there. Yes. All right? So we're going to say for A, there's a stretch of 3, right 4, up 2, and reflected over the x-axis. And then we'll talk about what the actual graph looks like in a few minutes. All right? So, yes, absolutely, we've done this. And this is for the absolute value. That's what he brought up. All right? And that's what I'm saying. Since we already discussed the absolute value, this is really easy because the same rules apply. On the absolute value, I wrote this, though. Y equals a parentheses x, or absolute value x minus h plus k. Nothing different. It's just the shape of the graph. So next year you'll be graphing like square root. It's the same thing. A square root x minus h plus k. Everything is the same. You just have to understand what the square root looks like. All right? So for letter B, we would say it's a vertical what? Stretch of shifted left 3 and down 8. Any issues with that? All right, so C, let's talk about that. Vertical shrink this time of what? 1/2 shifted. That's how simple. All right, last one before we go on. Let's take a look at number or letter I. So we say for I, it is a, wait a minute, am I doing this right? Is this I? Stretch of what? 4, then what? Reflected over the x-axis. I don't care what order you put them in. Right 3 and down 2. All right, so all of that is pretty much a breeze now. All of those. Okay? It says, as you describe the graphs of the quadratic function above, you wrote that it shifts to the left or to the right and up or down. What is actually shifting? What? Exactly correct. Thank you very much. The vertex is what's actually moving. All right. Very good. Very, very good. Okay, so now if somebody asks you to write an equation for the quadratic that opens down, shifts left 3 and up 7, you should be able to tell me that would just be what? I'm listening. Go. Beautiful. That's exactly right, guys. Told you, it's very simple. It's just knowledge based. I can teach this to anybody because it's just rules. You have to know the rules. All right, any questions? Any questions so far? All right, so let's move forward here. All right, is a quadratic function 1-to-1? Now let's look at this real quick. All right, this right here is a line. Is a line 1-to-1? Yeah, because every x has a single y, and every y has a what? Single x. All right. Now, is absolute value, since we've already done that, is that 1-to-1? No, because they could, the y value, all right, can be shared with what? 2x values. Now, how do you tell if it's 1-to-1? You simply do a vertical line and a horizontal line. Is the vertical 1-to-1? Yes. Is the horizontal? No. All right, so that's how easy it is to tell. So when you graph a parabola or a quadratic, it's the U-shaped. So is it 1-to-1? No, it's definitely not. All right. So if something is not 1-to-1, this is kind of advanced. You'll definitely do this next year. Then it has no inverse. All right. It has no inverse. All right. All right. I think you guys can do all that. All right. Now what I want to do is I just want to actually get to the graphs. All right. So let's take a look at letter A on that. All right. So this means we're shifting what? Right 3 and up 1. When you shift right 3 and up 1, that is the actual what? Vertex. All right. Now, here's what I want to show you next. All right. Is there a stretch? No. So now you got to pay attention. Listen to me. What's 1 squared? 1. So I go over 1, up 1. Left 1, up 1. Now I'm moving 2 units away from the vertex. So it's going to be what? The y value is going to be up 4. That's right. 2 squared. Thank you. So from this point, I go over what? 2, and then up what? 1, 2, 3, 4. Left 2, 1, 2, 3, 4. All right, and now hopefully you can see the outline of the parabola. All right, that's what it looks like. Very, very, very simple to do. Very simple. All right, so now let's see if there's anything harder. So here, the vertex would be what? Left what? And so go left 4 and up 9. That's your vertex. Now it's going to be reflected, so that means it's going to be opening down. So now we go to the right one.
And to the left one, and then down.
Yes, we go to the right one and down 1. Left 1, down 1.
To the right 2.
Then to the right 2 and down what?
4.
And there you have it. All right. Now, if you wanted to, you could say to the right 3, then you would go down what? 9, but usually it's not a big deal. So here we go. We're going to look at this as the graph. Now, let's just review real quick. This right here, this line, can you remember what this line down the middle is called? No. What's that called? No. What's that called? From last year. The axis of symmetry. Yes. That's called the axis of symmetry because everything on the right matches everything on the what? On the left. So if you were to look at this right here and count over, that would be 1 unit. That would be 1 unit. This would be what? 2 units and 2 units. So it's symmetrical. All right, that is called the axis of symmetry. All right, so let's take a look at the next one that I want to look at is to demonstrate what is meant by a vertical shrink. All right, so again, most people don't know this, so please listen. All right, so the vertex gets moved where? To the right 5. So everybody goes 5, 0. Now, why does the 1/2 not apply to anything there? Because half of what? 0 is still what? Because the y value itself is what? 0. So if I take half of 0, I'm still at what? 0. All right, now the hard part. All right, so normally I would go what? To the right 1 and up 1. Right? Listen, because 1 squared is what? 1. Now, instead of going up 1, I'd have to go up what? 2. No.
Up 1.
Say it. You go up 1/2. Because listen, the 1/2, hear me, the 1/2 literally means you're multiplying all the y values by what? 1/2. So, from this point, 6, you'd go over 1, then you'd go up 1/2. Left 1, up 1/2. All right? Now, the next point is you go over 2. Normally you go up 4, but in this case we're going
1. Up 1. Up 2.
why?
Because it's
Half of 4. That's right. So you go over 2. Normally you'd go up 4. 1, 2, 3, 4. But then you take half of it, so that drops it down to 2. All right? That's what I need for you to make sure that you understand what I'm saying. Just to make sure, if I go over 3, I would normally go up what? 9, but now I'm going up 4.5. So 1, 2, 3, 1, 2, 3, 4.5. And now you get the outline of the curve. And then what I'm going to do is I'm going to show you something about why they call it a shrink. Okay? So that's what that looks like. All right? And then we'll be done after this. All right? So please listen because this is important. All right? So now I'm going to change this to a different color. So normally it would be this, and then it would be this, and then it would be here. Now, what I'm trying to tell you, or what I'm actually trying to demonstrate to you, is the red would be if it was just x squared. So hopefully you can see how the original is being what? Compressed. All right? In your, later on, they'll just call it a compression. But right now, it's shrink, compress, whatever your math book says. All right? Is everybody with me on that? So again, you're supposed to understand why it's considered a compression or a shrink. Because all the y values are being what? Reduced. All right? So that's exactly right. All right? So now, again, I don't think this lesson is very hard. It's just the basic graphs. So if I'm going to let you study, then let's just talk about here. I want you to highlight these because it's so redundant and I think it was good. All right. And the reason why I think it's good when it's redundant is for some of you guys who need the extra practice can do what? Do some extra problems. All right. So the ones I'm highlighting are the ones I want you to take care of tonight. All right. I know it's kind of annoying because it's not numbered. I'll number it next year. I don't know what I was doing. And then let's do this. Match all the graphs. That's really easy. All right. So now, quiet and study. All right, quiet and study.
Will you go back to the top page to see?
Yep.
Because I missed the middle row.
The middle row. All right. And then tomorrow we'll finish this up.